Okay, we're going to learn 3 different methods to finding an inverse. So let me see, is this actually example 1? It doesn't say example 1, but does it say example? Oh, it is example 1. So we're just using the A from example 1, right? So we're taking A, which was 1, 2, 3, 4. Oh, okay. From example 1, and then we're finding the inverse and showing that it's the B inverse in example 1. Okay, I see. So, taking our 1, 2, 3, 4 matrix A, and we're going to put the identity matrix here. And now we want to use row operations to get our 1s and 0s here instead, just like we did in section. So, we start with the 1 in the top left corner. Done. What do we do next? Next, what do we want? So we want a 0 in the bottom right, or bottom left. Sorry. How do we get a 0 in the bottom left? Yeah, multiply the top by a -3 temporarily, and then we're going to add it to this one here, right? Okay. So 3 times -3 times 1 is -3 plus 3 is 0. -3 times 2 is -6 plus 4 is -2. The way I keep losing my train of thought today. Guess what? I should have just kept going. Anyway, -3 times 1 is -3 plus 0 is -3. And -3 times 0 is 0 plus 1 is 1. So my bottom row I have changed by taking the top row, multiplying by -3 and adding it to the bottom row, but then I'm keeping the top row exactly the same as it was before I multiplied the -3. So help me double check my work, because the way I've been going today, I have this fear of making mistakes. Okay, next, what do we need in the bottom right corner? A 1. So how about if we multiply by -1/2? So multiply by -1/2, that's going to give us 0, 1, +3/2, and then -1/2. Did I do those right? Okay, and then last, we need a 0 in the top right corner. So we're going to multiply this by -2 and add it here. So -2 times 0 is 0 plus 1 is 1 still, like it should be. And -2 times 1 is -2 plus 2 is 0. Here's the hard part. -2 times 3/2 be -3. -2 times 3/2 is -3. Sound right? And then -3 plus 1 is -2. And then -2 times -1/2 is a +1. And +1 plus 0 is 1. So now I have my identity matrix in here. And that means that A inverse is -2, 1, 3/2, -1. Oh. Now, if you look back at the problem we just looked at, example 1, that is matrix B, which we just proved is the inverse. Perfect. Okay. So method 2 is just using this weird little formula thing. It only works for 2x2s. Formula 2x2s only. Let's go ahead. It won't take us very long. So our matrix is 1, 2, 3, 4. So the inverse, the first part is the weirdest part. 1 over AD minus BC. So you're going to literally multiply those two numbers together and then subtract the product of those two numbers. So A times D. So 1 times 4 is 4. then B times C is 6. So we're going to go 4 minus 6, so that would be negative 1/2. So that's like the scalar. You're making a scalar out of that. This is actually called a determinant. We're going to learn more about that in section 6.6 on Friday, which I will record and hope to have you join me by Google Meet, if you will. But otherwise, I will record everything for section 6.6. Okay, so then we want to trade A and D. So notice how A is here and D is there, but in our formula, D is there and A is there. We're just trading those two numbers. So instead of a 1 in the top left and a 4 in the bottom right, we're going to switch them so we have 4 in the top left and 1 in the bottom right. Then here we have B and C. Notice how these are still B and C, but the signs are changed. So we take B, which is a 2, and change it to a negative 2. We take C, which is a 3, and change it to a negative 3. Do you see how I followed the formula? It's just like instructions, right? Telling you what to do with each number in each position. Okay, so now I'm taking the scalar negative 1/2 that came from doing 1 over 4 minus 6, and I multiply that times 4, negative 2, negative 3, 1, and I get negative 1/2 times 4 is a negative 2, negative 1/2 times negative 2 is a positive 1, negative 1/2 times negative 3 is a positive 3/2, and negative 1/2 times 1 is a negative 1/2. Exactly the same answer, without having to think through the row operations. So advantage, plug and chug. Disadvantage, another formula to memorize. Also only works for 2x2s. Right, method 3 calculator. I don't know what kind of technology you even have at home to use, so I don't think we have the time or we'll take the time to do that right this second. But I may create a video just showing you how slick it is. So you just type it in, and I'll use my TI Inspires to just show that process. Okay. All right. What else do we have going on here? Do we have time to get into the meat of what we're trying to accomplish? So, number 4 is finding the inverse of a 3x3 using the ugly method we just learned. So that could be complicated. I'll create a separate video of that. So what I want to do is we have like 4 minutes. Let's jump into learning about solving a system using an inverse matrix. Okay. So instead of taking the time to delete this, I'm just going to talk through it. So for a system, a number times x plus a number times y equals a number, and a number times x plus a number times y equals a number. We've been seeing this all chapter already, right? We used row operations last time with systems of equations. We turned our systems of equations into matrices, and then we used row operations to find our answers. So here's how this works. Since this is in matrix notation, let's say we have a matrix times the answer matrix equals another matrix. That would be saying that these coefficients A, B, C, and T are our one matrix. X and Y is our matrix. So this is like our coefficient matrix because it's the numbers next to the variables. This is our variable matrix because if we were to multiply this times this, notice how you would get A times X and B times Y, and you would add those together. You just get that equation right back. And then E and F is the constants. That's what we're trying to get those equations to equal. So because with a regular equation we can divide X by the coefficient to get the answer, we're not dividing, instead we're multiplying by the inverse. So we can find the inverse of matrix ABCD and multiply it times matrix EF. Then we can just multiply them together and get the answer that way. And it's really easy multiplication because how many columns does matrix EF have? Or matrix B is what we were calling it earlier. How many columns? It's one column. So if you're multiplying, that means you're only taking the rows, each row times that one column. And you're getting one column of answers. And that'll give you your answer for x, your answer for y, and your answer for z, or if it's just x and y. So, that's how you're still trying to write this down.